Astronomy used to be about staring up at the unchanging heavens. So this search for transients, things that go bang in the night, is truly revolutionary. But it all depends on astronomers' ability to monitor the whole sky. So I've come to the University of Leicester to see how this is done. This is the UK base of SWIFT, a space-based telescope designed to search for GRBs, gamma-ray bursts. Brilliant flashes of light that last just for a few seconds. It's thought that some of them are caused by neutron stars collapsing into black holes. The problem is that they're rare, and so SWIFT has to do two things. First, it has to scan the whole sky to spot when a GRB occurs, and then second, it has to swerve to get the data before it disappears. So we're here because you're controlling the spacecraft. This is not what I thought mission control would look like. So what's your role?
I am one of a team of observatory duty scientists, ODS for short. Everything is so well designed now, because as long as you have access to a computer and you can log into the relevant computers, we can do everything.
So how quickly can SWIFT respond once it's detected something?
Quickly. So the maximum speed we can slew at is about 1 degree a second. This typically means that for most gamma ray bursts that we detect, we'll be on target between 1 to 2 minutes.
And that's important for the science.
It is, yes. Gamma ray bursts may be the brightest explosions in the universe since the Big Bang, but they fade really quickly, so you have to get on there as fast as you can.
If you're not SWIFT, you miss it.
Exactly.
At 8:33 a.m, there's an alarm. SWIFT has spotted something. Phil Evans, the BA, or burst advocate, immediately starts to analyse the new data. And Kim gets on the line to her counterpart at the Goddard Space Flight Center in Maryland to see if they've noticed the same event.
Hi Amy, it's Kim and the Leicester crowd. Yes, it's NGC 224 that is the nearby source.
No, it looked like it could be something in there though.
You mean that the one big spike before the
Yeah.
Yeah.
Could it be an SGR in M31?
I mean, it's less than 6 sigma though.
Yeah, and I guess XRT didn't see anything.
Okay, we've now got a spur
Yeah,
NAC.
it's got lots of stuff in it, but no point source.
This feels almost like something from science fiction. Within seconds, Phil has more information about the location of the source. Did I hear it's M31, the Andromeda Galaxy?
Yeah, so the thing is M31's full of sources. So we found
enormous on the sky as well.
It is as well, which doesn't help. So we found an object which is a known object, which is that one there in this image. So there's the core M31's off here.
Right.
The issue is this just because that object is there, or is it suddenly got brighter? And for some reason, I'm not getting a brightness of this new source.
The problem is, the signal is very faint. And what's more, it's buried in a galaxy chock full of other sources of radiation.
A sort of vague source. The automatic system didn't detect anything, but by eye it looks like there might be. So they were trying to see if they could figure out what was going on. I'm assuming the answer was no to that.
I haven't yet managed to get a light curve. I know why. It's because it's
okay. No, that's not what I was asking. Well, I mean, we could say possible burst if you want.
I don't know what I want. I don't know.
You're the BA. I'm going to leave this in your hands.
No, give us a second. Let me just think.
After more discussion, Phil and Kim decide the trigger probably wasn't a GRB, but instead came from some other source within the Andromeda Galaxy. So, Kim, what just happened?
So, SWIFT triggered on something. We slewed around rapidly. We were on target in 74 seconds, so just over a minute.
It's impressive.
It then went on and showed us that not only have we detected one known source, we detected 5 known sources. So it took us about 45 minutes on that telecon. If it had been a real GRB, probably more like 15, 20 minutes.
So the satellite's back to its normal job and we're back to waiting for a burst.
Exactly.
A few hours later, the story changes again when Phil and Kim call the American team with their report.
Yeah, Jamie, this is Phil. Can I just mention this morning's event, because there's a couple of queries about it.
They've noticed that the same telltale signal was also seen by a second telescope called Fermi. More pressure now on Kim and Phil to come up with an explanation.
But there's a possibility of something interesting here, so we shouldn't throw it out. My suggestion, if you could identify what that source is, then we can rule it out as interesting. That doesn't confirm that it's real, but it makes it a little bit more plausible.
Agreed. Plausible.
Yeah.
Well, that was exciting. It turns out while the team here were running about this morning, the Fermi gamma ray burst hunting satellite also saw something. And so the fact that there was something seen by Swift and Fermi means it's worth going back for another look. So that's what the spacecraft's doing right now. For the next few hours, Kim and Phil are back observing M31 and reconsidering their data.
Continue monitoring this variable AGN to get a good optical to X-ray SED.
And later, they have a new theory. After running the numbers, they still believe that what they saw isn't a gamma ray burst. They think it's an unusual object, bright in X-rays, that's actually been seen before.
The object is called Swift J0243.6 plus 6124. Really sticks in the mind. It's named after the position in the sky. So this was first detected by Swift on the 3rd of October. We had a trigger and we didn't know if it was a new gamma ray burst or a galactic transient. So we kept collecting data and the X-rays stayed bright. Now for a GRB, the X-rays, the afterglow in the X-rays will fade fairly quickly over time. The fact that they stayed bright told us it wasn't a GRB and it was some kind of transient. So it's still getting brighter at the moment, so we may trigger again. We'll just have to wait and see.
Kim's day is over by 7 p.m. Any new activity now will come direct to her phone, and she'll have to deal with it at home. Which is, of course, exactly what happened next. A genuine gamma ray burst was detected at 12:07 a.m.
So, just after midnight on the early hours of Saturday, Swift triggered on a GRB.
So what do we know about this burst?
It's a long gamma ray burst, so this means it was a very massive star originally, more than 40 times the mass of our sun, and it just got to the end of its life. So at that point, it all collapses in on itself, and as it does this, stars rotate generally, so everything's spiralling round in, and you get jets of material shot out. And if those jets are pointing towards us, Swift can detect it, and that's what we see as a GRB.
I can see now just how pressurized observing transient events is. And it makes sense, because with something that's over so quickly, decisions have to be made fast and often on the basis of incomplete data.